Let's try to solve another leet code problem. 2470, number of subarrays with LCM equal to k. So let's first try to understand what is LCM. So LCM is the least common multiplier. So for example, for numbers 2 and 6, so what is LCM? So the least common multiplier of 2 and 6 is 6. So what about 2 and 3? Yeah. So let's just try to check the LCM, least common multiple of two numbers. So that is for LCM of two numbers. So for example, 2 and 3, LCM equal to 6 with 2 and 3. Yeah. So if we know about this, normally we can solve the problem. And the second is about how to calculate the LCM. In leet code, we can directly use LCM. Let's just try to use an example. So for example, 2 and 6. Yeah, let's just try to return this result. So result should equal to this one. Let's just check if it is 6. Yeah. Now, as you can see, the result is 6. It means this is for LCM. But you can also write a function if you want to make a write a function. So for example, for AB, and you can return directly a times b divided by GCD. Yeah, GCD of a and b. So GCD is the greatest common divisor. Yeah, so they have some connections. So now let's just check, because if I do not change anything, if I directly use a function, now this LCM will be my function. Now let's just check what is inside. As you can see, it is still 6. Yeah. Now, if we know about how to calculate the LCM, basically, we've already solved part of the problem. Let's just try to use the first example. Yeah. So for this example, for this number 3, we don't know the LCM because we need to at least have two numbers. So let's just set an initial number to be 1. Yeah. So for LCM of 1 and 3, so the result gonna be 3. So for this 1 and 3, the LCM gonna be 3. Yeah. So for this number 3, it is okay because 6 divisible, this number k divisible 3 is equal to 2. It is okay because normally 6 modular 3 equal to 0. So this means this 3 is okay. So we're gonna take it. But we're gonna not record the result because it must be 6. Yeah. Now we're gonna continue to check. Currently, this LCM gonna be 3. And now we're gonna continue to check this LCM of 3 with 6. So LCM of 3 and 6, so it is 6. Yeah. So if we get a result of 6, it means it is one of our answers. So our result would plus equal to 1. Because this 6 is our answer. So now we have a subarray of 3 and 6. It is okay. Yeah. Now we're gonna continue to check. So what about 3, 6, and 2? Let's just check 3, 6, and 2. Because currently, for the result of LCM is 6. So the LCM of 6 with this number 2, it is also 6. This means this is also okay. So we need to plus another 1. So this means 3 and 6 is okay, but 3, 6, 2 is also okay. Now we're going to continue to check with this 7. Yeah. So while we are checking this 7, so the LCM of 6 and 7, so what is that value? So it's gonna be a bigger value. Definitely, this value gonna be bigger. But let's just make it maybe, yeah, let's just make it 42. Yeah. So if this number is too big, so it is not okay. So this means this number, like 42, this number must be a divisor of 6. It means k modular this number. Maybe this number, let's make it as answer. Yeah. So k modular answer must equal to 0. Yeah. So if it is not equal to 0, if it is not equal to 0, so this means we're gonna break it. We're gonna break the loop. Yeah. So for example, this is 42. 6 modular 42. Definitely it's gonna be 6. So it is not equal to 0. So we're gonna break. So this means the first for loop from this 3, we're gonna break it. Now we're gonna continue to check from this number 6. So this is the brute force. we just need On squared to solve the problem, because N is just equal to 10 to the power of 3, so this means it is okay, totally okay. Now we're gonna check 6. 6 okay, we're gonna record as 1, and 6 2 as another one, so plus 1 and plus another one, so this is gonna be 4. Yeah. Now we're gonna continue to check with the 7. Of course, 7 is not okay, we're gonna break it. Yeah. And for the next loop, we're gonna, let me clean a little bit. For the next loop, we're gonna start from this number 2. Yeah. So for this number 2, and we're gonna calculate the GCD with 2 and 1, so it is a 2. So for this number 2, it is okay, but we will not record the result because it is not equal to 6. If it is equal to 6, we're gonna record it, but we're gonna continue to check. So for this 7, maybe 2 and 7 gonna be a possible result, but 2 and 7, the LCM of 2 and 7 gonna be equal to 14. Of course, it is not. Yeah, because this number 6 modular 14, it's gonna be 6. It is more than 0. It's not equal to 0. So we're gonna break it. Now we come to this number 7. Yeah, we come to this number 7. Of course, 7 is not our result. And now we're gonna continue to check this number 1. So what about GCD of 1 and 1? GCD of 1 and 1, of course, it is 1. But 1 not equal to 6. So this means we will not record the result. And this finished all the loop. Now we're going to continue to use brute force to solve the problem. So let me just set a result and N. So the result is going to be starting from 0 and N going to be length of the nums. So result is used to check how many possible cases, because finally I'm going to return this result. Now I'm going to loop through the nums. So for I in range for N, and I'm going to prepare an answer, because while checking the LCM, I have to use the LCM from the beginning. So the answer is going to be 1 from the beginning. And then I'm going to check index j. So for j in range, so where going to j be starting? Of course, it's going to be starting from I. Yeah, because we're going to check all the possible cases. So this is going to be a brute force. Yeah. Now we're going to prepare the answer. So the answer will be updated to LCM. So LCM would be the answer with this number. So the number is going to be nums j. So we're going to check this answer. Now, if this answer equals to k, it means it is one of our possible results. Of course, our result would plus equal to 1 because it is equal to k. And if it is another case, as I said before, if k modular this answer equals to a value, but definitely not equal to 0. Yeah. So we're gonna break it, and we're gonna go for the next I loop to check. Yeah, maybe there's other possible cases. Because for the first one, we're gonna check 3 and 6, it is okay. 3, 6, and 2, it is another case. And then for 7, it is not okay. So I'm gonna start from this 6. 6 is okay, 6, 2 is okay. So there will be only 4 cases. So that's gonna be the final answer. Yeah. Now let me just run it to check if it works. It seems okay. Now let me submit it to check if it can pass. As you can see, it passed and it's pretty fast. Now let's analyze a little bit about time complexity. So for the outer loop here, this is On, of course, and from here, and this is another for j in range from I to n. So we're gonna say it another On. Yeah, basically this is On, and this is another On, and for the LCM, definitely for this LCM, we use the GCD. So for the GCD, it is just log n time. Yeah. So technically, if we want to check this kind of time complexity, we can say it as n squared times log n, because this number is going to be really small, like 1000. So it means basically it is 1000 10 to the power of 6 times log 1000, and log 1000 is just another 10, so it is 10 to the power of 7, so it means it is okay. Thank you for watching, see you next time. Yeah, but for the time complexity, maybe it is smaller than that. Yeah, because here is another check. If this modular k modular this answer, it's gonna break immediately. Yeah, but I will ignore about that. We're gonna just focus on these areas. I think it is still okay. Thank you for watching. See you next time.